For this question, we are given the equation x squared times y squared minus 16x equals 2, and we are asked to find the second derivative of y with respect to x. In order to find the second derivative, we will need to take the implicit differentiation of this equation because we cannot get y alone. So first, we differentiate the product x squared times y squared, and we apply the product rule. Well, derivative of x squared is just 2x. Okay, by the product rule, we need to add x squared times the derivative of y squared, which is 2y dy over dx, because y is a function of x. Then we continue to take the derivative of negative 16x to get negative 16, which equal derivative of 2 constant is 0. Now we need to solve for dy over dx, so we push all the non-dy over dx term to the right hand side. So we will get 16 minus 2x y squared. Then we divide both sides by 2x squared y. So on the left hand side we get dy over dx, and on the right hand side we will simplify because 16, 2 and 2 have common factor of 2. So we divide each number by 2. 16 divided by 2 we get 8. Now we need to find the derivative the second derivative of y with respect to x, and because it's a quotient, we will apply the quotient rule. The quotient rule tells us that the derivative for the denominator we should get x squared y quantity squared. For the numerator, first we get 8 minus x times y squared, and we take the derivative. So we get, well, derivative of 8 is 0. Derivative of x times y squared, we apply the product rule again. So we get negative 1 times y squared minus x times 2y times dy over dx. We multiply this by the denominator, x squared y. And then we subtract the numerator times the derivative of the denominator. Again, product rule, we get 2x times y plus x squared times dy over dx. Now we just need to simplify. When we simplify, we distribute each factors. So negative 1 y squared times x squared y, we get minus x squared y to the third power. We subtract 2xy times dy over dx. We need to replace it with the expression for dy over dx. Well, when it multiplied by x squared y, we should get 8 minus x y squared. Next, again, we continue distributing. So we get 8 minus x y squared times 2xy. Well, we notice this expression and this expression are the same. So we can combine them and we get 2 of them. So altogether, we will get 4. Continue distributing. We get minus 8 minus xy squared. Then this time we multiply by x squared times dy over dx, which we should get 8 minus xy squared divided by y back. And then altogether we are dividing each of these by x to the 4th power y squared. Now we end up with this expression, and we just need to continue with our work by simplifying. First of all, we notice in the denominator we are dividing by y. We don't want to handle complex fraction. So we multiply the top expression and the bottom expression by y. So we increase the power of y on each term. Right here we get y to the 4th power. There we get y squared. And here we get rid of the y. And right here we also multiply by y, so it's y cubed. Now we continue simplifying. Bottom we have x to the 4th power y cubed. Denominator we get minus x squared y to the 4th power minus 4x y squared times 8 is 32 x y squared plus 4 x squared y to the 4th power. For the next part, we use the binomial formula. So we get minus a squared, 64, plus 2 times a times x y squared, so we get 16x y squared. And we subtract x squared y to the 4th power. Finally, we combine like term. Minus x squared times y to the 4 plus 4x squared y to the 4th. So right here, here, and here we combine the like term to get 2x squared y to the 4th power. We combine this and that to get minus 16x y squared and subtract 64 finally. And this is our expression for the second derivative of y with respect to x.